Alrighty, as promised, we have a second video here picking up with question number 8. So right here on question number 8, once again, let's pretend you didn't see that answer. We have rules of exponents that we have to apply. And normally when you have x's on the top and x's on the bottom, you could cancel out x's. However, because we have negative exponents, we have to use that negative exponent rule that says that whenever you have a negative exponent, you move that term with the negative exponent up to the other side and the exponent will become positive. So the x to the negative 8, I'm going to write it up here as x to the positive 8, and I'm going to scratch it out because it's no longer there at the bottom. And also the y to the negative 4, I'm going to move it up here and I'm going to write it as y to the positive 4, and I'm going to scratch it out because it's no longer at the bottom. So what do I really have here? I have x to the 8th times x to the 3rd. So we should all know rule 1 of exponents, that when you're multiplying with the same base, you add those exponents. So x to the 8th times x to the 3rd is x to the 11th. 8 plus 3 is 11. And then the y to the 7th times y to the 4th, the bases are the same, add the exponents. 7 plus 4 is also 11. So your answer is x to the 11th, y to the 11th. You're not going to put it over 1. I mean, technically you could, but you don't need to. So there's the answer, x to the 11th, y to the 11th. Okay, let's move on. So there's another rule of exponents that says whenever you have parentheses with an exponent on the outside and no addition or subtraction of terms on the inside, or another way of saying it, whenever you have a monomial on the inside with a power on the outside, you could distribute that outside exponent to each and every single inside exponent. And we need to remember that a power to a power, you multiply. So this is not the number 3. It's not 3 times 2. That's incorrect. This is an exponent. So the exponent gets distributed to the exponent of 2, which is really an invisible 1 right there. So 3 times 1 will give you the exponent 3. 3 times 7 will give you the exponent 21. 3 times negative 3 will give you the exponent negative 9. 3 times 0 will still give you the exponent 0. Okay. As a matter of fact, we could have scratched it out. Anything to the 0 power is equal to 1. You could have scratched it out here, or you could scratch it out here. Either way, you got to get rid of it because anything to the 0 power equals 1. So that's gone. Now, what else could we do with this? Are there any other rules of exponents we could apply? Absolutely. The y to the negative 9 power, that's going to get moved to the bottom of this fraction. Yeah, it doesn't look like a fraction, but you could put a fraction bar and move that y to the negative 9 underneath, make it y to the positive 9. And once you actually write it down here, you could scratch it out. You already moved it, it changed signs, you're good to go. The only other thing you could do to get your final answer here is simplify 2 to the 3rd. And again, that's not multiplication. That's 2 to the 3rd power, which means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we have 8x to the 21 over y to the 9th. That is your answer. 8x to the 21 over y to the 9th. Type that in, you'll get full credit. Moving on. And yet another question with exponent rules. Now, yes, we see some parentheses right here, but there is no power on the outside that we have to distribute, right? We see some parentheses here, but there is no power that we have to distribute. If there's no power on the outside to distribute, and you really don't need these parentheses at all. So what you really have here is 3 times x to the 3rd times 6x to the 4th, which is really 6 times x to the 4th. So in reality, all you're doing is multiplying the coefficient 3 with the coefficient 6. 3 times 6 is 18. And then you are multiplying x to the 3rd times x to the 4th. And remember rule 1 of exponents? When you have x times x, you add the exponents, right? That is 7. So 18x to the 7th power. That's your answer. If you're thinking, wait, why are we adding 3 and 4? Aren't we multiplying? Shouldn't I multiply 3 and 4? No, what does x to the 3rd actually mean? X to the 3rd actually means x times x times x. What does x to the 4th actually mean? It means x times x times x times x. So what do you really have? You have x times x times x times x times x times x times x. So that's a total of 7 x's. You add them up. After all, exponents really are multiplication. So yes, multiply coefficients. 3 times 6, that's 18. X to the 3rd times x to the 4th. Add the 3 and the 4, you'll get 7. There's your answer, 18x to the 7th. There it is. Moving on. And yet another problem with rules of exponents here, we're going to grab the negative exponent, circle it, draw an arrow, move it up to the other side. And when you move it to the other side, the exponent changes sign, which means that the -4 now became +4. Since I already moved it and wrote it up there, I could scratch it out. It's no longer at the bottom. It's now at the top. So what I really have here is x to the 4th times x to the 4th. Once again, when you're multiplying with the same base, you add the exponents. The answer will be x to the 8th. There's your answer, x to the 8th. Moving on. Finally, get to some more that are a little more fun here. We are going to distribute the monomial. This is a monomial. It's actually a quadratic monomial. We're going to distribute it into the quadratic trinomial. So we are going to distribute. Whenever I distribute, I like circling and drawing arrows. -4x squared times +6x squared. -4, so you're going to do the coefficients. -4 times +6, that is -24. And then we can move on to the x squared times the x squared. Add those exponents, that'll be x to the 4th. So we've distributed to the first term. Now take it and distribute it to the second term. That's a -1 in front of the x, right? So what is the -4 times -1? That's +4. So I'm going to put +4. And then, of course, I have x squared times x. X squared times x, add the exponents. 2 plus 1 is x to the 3rd. So x to the 3rd. And then distribute, last but not least over here, -4x squared times 7. A -4, again, the coefficient -4 with the number 7. -4 times 7 is -28. And just put that x squared on your answer. So -28x squared. -28x squared. Now the question is, could I combine any of these? Well, you might be thinking, yeah, they're all x's. X, x, x. Wrong, right? They're not all x's. This is an x to the 4th. This is an x to the 3rd. That's an x squared. They are completely different. They are not like terms. You cannot add anything. So that is your answer right there. -24x to the 4th plus 4x to the 3rd minus 28x squared. I hope you type it in correctly. Let's move on. This is a good one. We have an exponential growth or decay function. Who knows? But what we need to do is analyze the graph from left to right. Is it growing away from the asymptote or is it growing towards the asymptote? So there's many things that we need to know about exponential growth or decay functions. Here's the notation or the notes that we need to know. Y equals a times your base, which may be a growth function or a decay function. It may be a base that's greater than 1 or a value between 0 and 1. And then you have to the power of x. In algebra 2, you will have a minus h over here, but in algebra 1, all we deal with is the plus k over here. So the asymptote, I hope you remember, the asymptote is that imaginary line, this line right here. It's not an imaginary line, but it's a dotted line. You don't really graph it, but your graph, it infinitely approaches that asymptote. And if it does from left to right infinitely approach it, it infinitely decays towards that asymptote, that means that it is a decay function, okay? So a growth function will grow away from the asymptote. It'll grow away in a positive direction or maybe grow away in a negative direction. That'd be a growth function. But a decay function decays towards the asymptote from left to right, or in this case, decays towards the asymptote from left to right. The only difference is that this is down here, so that must mean that the a value is negative. Because if the a value were positive, it'd be up here somewhere decaying towards that asymptote. But if it's negative, it's going to be way down here decaying towards that asymptote. In this case, the asymptote is y equals 4, which also tells you your k value. The asymptote is your k value. Let me write that down. Asymptote is y equals k. So because this green dotted line is at the y value of 4, then your asymptote is y equals 4, which means that this number out here at the very end, it will be a plus 4, okay? Keep in mind, algebra 1 has algebra 2 has minus h. Algebra 1 does not, we don't talk about minus h. So the 4 is the k value. And once again, if it's decaying towards it, that means that this value must be a fraction, okay? And if it's down here, it means that your a value must be negative. So when I look at my answers here, I need to look for a negative out here in the a, which is this one. None of these others have, oh, this one does have a negative also. But what's the difference between this base and this base? Well, the 2 will make it grow from left to right away from the asymptote. And that makes sense because if you take any number and multiply it by 2, it's going to grow, right? 10 times 2 grows to 20. 5 times 2 grows to 10. But if you multiply 10 times half, that's going to decay down to 5, okay? So yes, this base is a value that's between 0 and 1. It's a fraction that's less than 1. That makes it decay, so it's gonna decay towards the asymptote. This one grows away from the asymptote from left to right. So from left to right, it decays towards the asymptote. The a value is negative because it's down here, and that's it. The asymptote is at 4, and the only one with the k value of 4 is either this one or this one. We said that this one's it because that's a decay function. All right, I hope this helps. Let's move on to the next question. Here we go again, another question that's growth or decay. And once again, from left to right, it should grow away from the asymptote. You can see that the asymptote's a dotted line, dotted line, dotted line. Those are your asymptote values. Which has the asymptote value of 1? Well, the asymptote value of 1 is up here. And obviously that first one is not up there, it's down here. So that one's definitely not it. Neither is this one. Neither is that one. Just by knowing your asymptote, you'll know that this is the correct answer. Just by knowing your asymptote, right? Your k value, okay? In addition to that, let's say you had a bunch of them with the same asymptote, then this, if it's a fraction between 0 and 1, from left to right, it will decay towards the asymptote. So this one right here, it does decay towards the asymptote. However, it starts up here. It's positive, and this is negative. Negative means that it gets reflected over the x-axis, so it starts down here and goes up towards that asymptote. Even though this is the wrong asymptote, the asymptote should be at 1. So down, look, negative sign, it's down here. It decays towards the asymptote. Why does it decay? Because it's a value less than 1, between 0 and 1. So it's decaying towards the asymptote of 1. So this is the only one with the correct answer. I hope this helps. If it doesn't, if you're still confused, please come and talk to me in class or before or after school. Moving on. Another system that we need to solve, and you could use substitution. I think we concluded that linear combinations is the most comfortable, that you guys is the one that's most comfortable. But you guys know what I'm saying. Linear combinations is what we've been practicing the most in class. So that's what we're going to use. So you could subtract 7x, subtract 7x. That way this top equation will be organized with your x's first, negative x, plus y equals positive 4. The bottom equation is going to stay exactly the same. It's going to be 14x minus 2y equals negative 8. Now, you could decide to cancel out your x's, or you could cancel out your y's. I would rather deal with smaller numbers like 1 and 2 as opposed to 7 and 14. So I need to think, how am I going to get this negative 2y to cancel with this? Well, this would have to be the exact opposite of negative 2y, so I need to make this a positive 2y. How am I going to change a positive 1y to become a positive 2y? Well, you're going to multiply the whole top equation by 2. So when I do that, 2 times negative 7 is negative 14 with an x. 2 times 1y is positive 2 with the y. And 2 times 4, that would be 8 right there. The bottom equation is going to stay exactly the same. 14x minus 2y equals negative 8. Now I will be able to combine the lines and eliminate those y's, right? The y's, the 2y and the negative 2y cancel out because they're exact opposites. However, when you look at this negative 14x and that positive 14x, that also eliminates. Not only that, over here, the 8 and the minus 8, that also eliminates when I combine them. So what do I have? Nothing left on the right, on the left side of the equal sign, nothing left on the right side. 0 equals 0. That is not false. That is true. That is always true. When is 0 equal to 0? Always. So what does that mean? That it's an infinite amount of correct answers, infinitely many solutions, right? So if you look over here, infinite solutions, that's going to be the correct answer. What would that mean visually? That they are the same equation, all right? So this is already, this is already set up to graph y equals mx plus b. If you were to get the y by itself right here by subtracting 14x, dividing everything by negative 2, you end up with the same exact line. So if you graph one line and then you graph the other same exact line, how many points do they have in common? Infinite amount of points in common, infinitely many solutions. A shortcut way of knowing, if you end up with your x's and your y's canceling, and even your numbers, you have something that's always true, infinitely many solutions. If the x's and the y's cancel, but your numbers don't, like if you had 0 equals 16, then you would say no solution. Okay, infinitely many solutions when it's always true, no solution when it's impossible, like 0 equals 6, right? Moving on. This one's easy. You just gotta know what's happening when you are multiplying two terms with the same base. You must what with the exponents? You must add the exponents. Add, right? So if you have x to the second times x to the third, what do you do with the 2 and the 3? You add them, x to the fifth, okay? And then let's keep reading. When you have a power to a power, you blank the exponents. Well, you multiply the exponents when you have a power to a power. Everybody should know that. When you have x to the second to the third, that's a power to a power. That's when you multiply and you get x to the sixth. Alrighty, guys. I'm done. You guys need to study. Good luck on the midterm.